Okay, so this is going to be lab number 6. This is all about safety programming. So we are going to show how to do some basic devices using the Rockwell safety logic. This is the factory I/O that we're going to use. Now, if you look at it here, we've got, oops, put that back in place. We have safety gate, so 2 different safety gates. Here we have what we are using as a light curtain. So the boxes will pass through that open spot in the fence, and we'll treat that as a light curtain. And we have 2 e-stops as well. One here, and one on the back of the cell as well. Right there. So, if I bring up this here, it's basically 2 safety gate switches, 2 e-stops, 1 light curtain, and the strategy we're going to use here is the gantry is okay to run if all of our devices are good. So we need all of both e-stops okay, both gate switches okay, and the light curtain okay in order to be able to run the gantry. For the conveyor, the only thing that's going to stop the conveyor will be the e-stop. So if the gates are open or if the light curtain is violated, the conveyor will continue to run. So we are going to set up our zones like that. And when we are doing this simulation, we need to remember that this is, we are learning how to program the software here, but the setup we are using is not a real world setup. So if this was real world, we would be using true safety devices that would have to be actually wired with 2 independent safety signals as inputs that would come into safety rated input cards that we would then use in our safety logic. We would then be controlling safety rated outputs that would be running safety contactors like we're showing here, and these would be physically interrupting power to either the conveyor or the gantry. Now, because we don't have physical devices that we're using, we are just going to go through the process of making the logic that does that. So when we actually stop the conveyor, it's not that we're interrupting power to it, we are just stopping it via software, which we would do in a regular application as well. But in addition to that, we would also be physically removing power from the conveyor by means of safety contactors as well. So we would be shutting down the conveyors and gantries by 2 different methods if this was a true safety application. We can't really demonstrate that in Factory I/O, so we are basically going through the motions of setting up devices that would control those safety contactors, but it's really just the software that is stopping it. So just keep in mind that we are learning the basics here, but we are having to cut some corners and make some creative solutions to actually make this work in a simulated environment as well. So remember, this safety contactor is what we're controlling with our safety logic, and then what's actually making it stop in the simulation software is just being done in our standard logic. All right, so let's have a look at this and look at the logic that we are starting with here. So our starting logic, and much of this is going to be done for you to start with. I will explain what is going on here. So you're going to start with this program. So you'll notice now that we are using 2 different tasks here. We are using the main task, which controls the standard logic. This is where all of our motions are going to happen. And then this second task down here, so main task and safety task. So safety task is where we will be controlling the safety programming. The main task is pretty much done for you. You don't need to change anything here. So let's look at this. So we have some logic to control the conveyors. It's basically a start-stop circuit to get run mode, and then running our conveyors. There's nothing fancy going on there. The gantry is basically just moving off of a timer. So every second or so it does another motion. That's basically all that it is doing, and it is allowed to do that as long as we have this sell OK signal. We have some logic that runs these safety gate boxes. They basically control the lights and buttons on the safety gate boxes. We don't need to get into that. And then this one here, this R99 safety signals, this is where we are doing some manipulation of the safety devices, because like I said before, a true safety device would give us two normally closed signals to indicate that we would get and wire into safety input devices. We do not have that in our PLC or in our setup because we are not using physical devices. So we need to do some workarounds to actually make this work. So I will show you what we are doing for that. Just download this. Okay. I'll place this in run mode. And here we go. So let's look at this. I'm going to connect. So looking at my devices in this file right here. So this is the R99 safety signals. So this is how we have to get around this. So let's start down here with e-stops. So e-stop number 2, which is the front one here, you will see that this push button, Boolean 1, this is on right now. If I push that, that goes off. If I pull it back out, it is on again. So what I need to get from this is I need two separate signals that I can use for my safety logic. So what I have to do here is actually take that input and have it drive two separate signals, which I'm calling eStop to channel 1 standard and channel 2 standard. And I'm now going to send these over to the safety portion of the program. Okay, so this is the basic method that I'm going to do for all of these. So a standard signal cannot be used, a standard tag cannot be used in your safety logic. You can go the other way. You're allowed to use safety tags in your standard logic, but you cannot use a standard tag in your safety logic. So if you want to use tags in your safety logic, they actually have to come through a safety rated input. But there is one way around this. There's actually something up here under logic and map safety tags. You can actually go here and there's a whole table. And what we will do is we'll actually delete all of these. And we'll just start over here. So you can actually set up a mapping here and individually map tags from standard to safety. So what we are going to do is for all of these signals, we need to port them over to the safety portion. So starting here with this e-stop, so we want to take these two and send them over for use in the safety program. So this is e-stop channel 1 standard, and you will have to do this if you were setting this up in your project. And this is going to be called I believe it is e-stop push button 1 channel A. And then here again, e-stop channel 2 standard and e-stop, channel B. Sorry, I actually want to do this as e-stop 2. Sorry, this is called e-stop front channel A. And this one is called e-stop front channel B. Okay, so we'll do that. So that's this one here. This next one will be this tag here. And that is called e-stop 3 channel 1 standard. And I believe this is called e-stop rear channel A. So this process, which is going to be a little bit time consuming, stop rear channel B. So we've got those. Here's these resets. So zone 2 front gate reset standard. Zone 2 front gate reset standard. And then there'll be something in here called reset. Safety reset, I believe it is called. Gate reset front. Okay. That's what it's called. Zone 2 rear. I'm just trying to remember what my terminology is here. And again, the reason we have to do this is because we are not dealing with true inputs. We have to actually map these from the standard logic to the safety logic. So let's just do these ones for now. Now let's get this one here to the fault reset. Again, that was under logic, map safety tags. Fault reset standard. Goes to fault reset. Actually, might as well finish this. Yeah, let's just finish these. Okay. Z2 rear gate switch. Channel 1 standard. And this is going to go to gate rear channel A. Gate 2 standard is going to be gate rear channel B. Gate front standard goes to gate front channel A. Gate front channel 2 standard goes to gate front channel B. And then the last one here LCOK channel 1 standard, LC1 channel A, this is LC2. It's just LC. So LC2 channel 1 standard goes to LC channel A and LC channel B. Okay, so we think those are all good. So this is basically what that should be. I think that is correct. I'm going to close this. And let's look at what this actually does. So what we should now be getting, this gate, that's gate 1. That's our E-stop right there. That's our reset. This is our fault reset here. You'll see that's right up here, the fault reset. Over on the back side, the rear gate. open that up. We get that. E-stop. Gate reset button. And then we have the second fault reset button here too. And then the last thing, this light curtain. Now the light curtain, you'll notice, this actually has all these individual beams to it. This actually has beam 1, 2, 3, 4, 5, 6, 7, 8 beams. So I am looking for beam 1, 2, 3, 4, 5 to not be on, and beam 6 is broken, 7, 8 not broken. So you can see this one here, beam 6, it's actually broken by the conveyor right now. So this one is in the normally open position. And you can see if I pull this box into here, you can see how that's now breaking beams 3, 4, and 5. Or if I lift the box up here, it's actually breaking those beams. So that is basically how we're doing that. So if any of those beams get broken, we lose the light curtain OK. So now let's look on the other side. If we open up here the actual safety tags, we should now be getting a look at the safety tags here as well. Sorry, they're under controller tags. And you'll notice that the tags, you'll see some of them are classed as safety. So let's look at these tags right now. So let's look at light curtain. So light curtain, sorry. So here is all these things here that I created. It's all these different tags. So because I have that mapping set up, I should now be getting the so light curtain, sort these by safety. So light curtain channel 1, channel 2. So these ones here. So this should be 1s when this is not broken. And you can see how this drops down to 0s when that is broken. Okay, so you can see how that's affecting that, and that's because of that mapping that we've set up. So it's getting mapped from the standard over to these safety tags here. So those are now ready for use in the safety logic. Same thing with the front and rear gate switches. We should be able to see gate front right there, the e-stop front right here. See how those both go off. All right, so basically this is showing that those devices are all good. All right, so ready to start programming actual safety logic. So let's look at how to do that. So that's basically everything we're going to do on the standard logic. Let's get into the safety logic. So you'll notice here we have this one file that says signals do not change. We're not going to mess with this at all. This is just going to stay as it is. We have some things going on here that I'll explain in a little bit. But we have a main routine, and we're going to add some other routines in here. So let's start adding some routines. So we're going to add one separate routine for each type of device we have. So let's do that. So let's add a new routine. So let's add one called R01 e-stops. We'll do that. Let's add another one. I'm going to call it R02 gates. I'm going to say R03 light curtain. The numbering doesn't really matter. You can call it, and the names don't really matter. I'm going to say R10 zones. And then R20 outputs. Actually, I'll call it contactors instead. Now, I got a bunch of files here. Let's make sure they're being scanned. So add some JSRs in here. So add in e-stops. Gates, light curtains, zones, contactors, and make sure that last one, that R99, is being scanned as well. I will assemble all this stuff, and then let's start actually programming some stuff. So let's do the e-stops first. E-stops. So we said we were going to use the redundant input block for all of our instructions. So we can either type in RIN for redundant input, or we can go to the safety blocks up here, and you'll see all the different types of safety blocks. So let's bring in the redundant input block, and let's set this up. So we have to give it a tag here. Now I already have these tags defined. So let's just call this, I think it's called front, or e-stop2. Or I think we're calling it e-stop2. No, e-stop front is being called. That's the name of the tag. E-stop front. All right. Now we need to tell it what type of reset we are using. So do we want automatic or manual? Typically an e-stop is going to be a manual reset. So we actually need the button to be pressed in order to reset this. What are my two input channels? This is e-stop front channel A and e-stop front channel B. And we should be able to see this in action here. Those go to zeros. They go to ones when this is out. How are we going to reset this? We want it to be this button right here. And that button was gate reset front. That is this button right here. So that goes from 0 to 1. And then if this block were to fault, we have a tag that is called fault reset. And that is this button right here. Okay, so that is basically all there is to programming this. So now what we should be able to see, if we put this in, you can see this is actually activated right now. It has the 01 tag on. If we push the e-stop button, that disappears. You can see these inputs went from 1 to 0. If I pull this e-stop back out, the inputs come back on, but I don't get my output. I don't get the output until I actually reset that. And that's the difference between manual reset and automatic reset. If I wanted to put this into automatic reset, you'll see the difference here. I no longer need to push that reset button to get the reset action. So if I hit the button, this goes off. I pull the button back out and it comes back on right away. I don't need to do the resetting motion. But that is not what you want for an e-stop. Typically e-stops, you want to require that manual reset. And that is basically how we program the block for the e-stop. Now the second one actually becomes really simple because all we have to do is copy and paste this guy. This is called e-stop rear. I think this is just rear and rear. And these, oh, that's actually rear as well. The default reset is exactly the same. And we should be able to go over to the other one and basically see that operation there. So e-stop and then press the reset button and that all works. So that is operational. Okay, so that was e-stops programmed. So let's do basically the exact same thing for the gates. And the gates are almost identical as well. So let's just copy one of these again. The gate switches, again using the same redundant input block, except now it is, I think, safety gate, called safety gate front. Again, it'll be manual reset. I think this is called gate front. It actually uses the same reset button. So now if I open up this door, that goes off. I close the door, the inputs come back on, but I don't get the output until I push that button. Okay, so that's that one. Let's change this one to rear. And that one works. All right, good. Let's do a light curtain. And let's copy this again. Light curtain, almost identical. The only difference, light curtains typically, particularly in this case here, because it's just boxes going through there, we want this to actually reset automatically because we don't want to have to push a button every time that box goes through there. So let's do this. We're going to call this one, I think it's just called light curtain. And this was called LC channel A and LC channel B. And then because we're not using this, we don't even need a reset tag in here. So what we'll do is we'll just duplicate this fault reset tag right here. So make these both the fault reset. In there. So what we should see now with this box right here, if we push that box into the light curtain, it breaks. If we pull it back out, it resets, and it resets automatically. There's no button we need to press or anything. It's just break and reset. Break, reset. Okay, so those are our redundant input blocks. The next thing we need to do is figure out our zones. So how did we say this was going to work for the zones? So we said gantry is okay to run if all devices are good. Conveyor is okay to run if e-stops are good, don't care about the gates or light curtains. So we're going to have two separate zones we're considering here. So let's look at this. So let's make up a bit that's called, and this basically just programs like our regular logic. So I have a tag called all e-stops are okay. And this is basically going to be, we use the .01 flags from those blocks that we have. So you can see how that goes together like that. Sorry, that's an O1. It's an O, not a 0. So let's do that. So right now, all these stops are okay. See if I press that. Now all these stops are not okay. Reset it, and they come back on. All right, and then let's make a second one here. And let's call this one this is going to be called cell OK. And this is going to be a combination of several different things. So we're going to say, first of all your e-stops are good. And then you have safety gate front, O1. Safety gate rear, O1. And light curtain. So we need all of those things to give us cell OK. And you'll see once I have that now, this thing here starts running. But if I break any of these things, it will stop running. Okay. So that controls this, and basically you'll see I'm using this bit here and this bit here back again in my standard logic. So this was being used in standard logic to control. So there's all e-stops OK, and in the gantries I was using cell OK to basically control all my motions. So the last thing we're going to do is actually control the physical contactors. So that's these devices here. So based on e-stops OK and cell OK, let's actually control these physical safety contactors. That's the last thing we need to do. So what that will look like, we have a thing called redundant out. So that is another safety block called redundant out. And I have a tag already made that's called cell contactor 1. The feedback type for this, you can either make positive or negative. We're going to go with positive. And what signal is actually going to enable this? So these ones here, these are the cell contactors. So this will be the cell OK. So if we get that cell OK bit, this should try to turn on and turn the contactors on. And what we're going to monitor with those contactors is we actually want to see them physically close. So we will run wires through the contactors themselves to come back as inputs to these devices. So once we tell these contactors to close, we should actually get inputs back from them as well. So these are going to be called cell contactor 1 channel A and cell contactor 1 channel B. So that would be a physical input that comes back from the device. Now, because we don't have that, we're just going to kind of fake that, and that's what these signals do not change file is for. So we're basically saying when we turn on these outputs, give us these signals back. So that's what's going on here. So we're kind of faking around this to make it work, and it's our same fault reset for that. And the next thing we put down here, we get an O1 and an O2 from this, and we will say if you have O1 and O2, actually run the physical output. That's called Con1 real contactor, and this is what would actually go to control your physical output card, your safety rated physical output card that would physically control that contactor. So this will be the O1 and O2. And this is basically the way that we write these. So what you will see, we close this, do that, and you'll see this come on. So that would be actually turning on the real contactor. And the only other weird thing is that whenever we use contactors, we're always going to use them in pairs. That's our other aspect of safety. Everything is always done in pairs. So we have contactor 1, and then we will repeat that process again with contactor number 2. So we have a second contactor as well. So that is controlling the cell. The last thing we need to do is repeat the same thing again for the contactors that control the conveyor. let's copy all this stuff. Actually, just copy one of them and make the copy and pasting easier. And this one is called Conveyor Contactor 1. This is driven by all e-stops OK. Alright, so we have that. Let's just repeat that one more time. And then that is going to be it. We are done after this. Change all our 1s to 2s. Alright, so we have a button here. I'll start that conveyor. So if I hit e-stop, that drops these ones out because this requires e-stops OK. You'll notice when we go through the light curtain here, it shuts down the gantry, but the conveyor keeps on running. So as long as this box is in the light curtain, the gantry will not run. But the conveyor is still running. Okay. And that is the implementation of safety devices in our logic.